of g of x or g of f of x. Now, sometimes it might not exist. So how do we know if it exists or not? Well, if we're trying to find g f of x, that's pronounced as gof, we look at the range of f. And if it's a subset, that means subset, of the domain of g, then it's defined. And the same for the other one. So if we're trying to find fog, which is fg of x, then we look at the range of g, and if it's a subset of the domain of f, then it's defined. Right? Not necessarily that they're equal to each other. Very important. Okay, let me clear this one. Example 4. Find both fog and gof, state the domain and range of each, where. And it tells us that f is 2x minus 1 and the g, so g of x equals 3x squared. Okay, well, we should know this. This is a straight line. So the domain of f is reals and the range of f is reals. This is a parabola. So the domain is reals and the range, of course, being a parabola, is reals positive union 0. Now we have a look at them. Is f of gx defined? Well, we'll look at the range of g, and it has to be a subset of f. So the range of g, and there's a subset of f. Yes, the range of g is a subset of f, so this one is defined. Let's look at the other one. The range of f has to be a subset of the domain of g. Rules and rules, yes, is a subset, so they are both defined. Any questions there? Okay, now we're actually going to work them out. So we're going to substitute our g into our f. Our g is 3x squared, our f is 2x minus 1. So when I do f of g of x, I'm going to get my g and substitute into my x. I get 2. Then x, which is going to be times 3x squared minus 1. Of course, simplify, don't leave it like that. So I get 6x squared minus 1. Any questions there? Okay, do my gof. So doing this one, I'm going to get my f and I'm going to substitute it into my g. So my g is 3. Then x, my x in this case is 2x minus 1 because that's what my f equals, and squared. I can't simplify that one, so I'm just going to leave it like that. Further down, you'll see that the calculator, how to do it on your calculator, you can define your f of x, you can define your g of x, and then once you type in f g of x and g f of x, the calculator gives you the answer straight away. Any questions so far? Okay, we're a couple of people short. There's 19 people here. And that includes me, so that we're 2 students short. Okay, example 5. For the functions g of x, which equals 2x minus 1, and it gives us the domain, x is an element of reals, and f of x equals that again gives us the domain, state which f of g or g of f is defined. Well, let's sort of do this on the side where we're working out our domain and range. So we've got, I'm going to go domain, you don't have to write it like this, range, okay, I'm doing my f, I'll do my g of x here, my f of x here, okay, g of x has a domain of reals, and it's a straight line, so the range will be reals. F of x equals the square root of x, and the domain is x being greater than or equal to 0. And remember, square root of x looks like that. So this is y is greater than or equal to 0. Okay, just going to change. So when I look at fog, I'm looking at the domain range of g. Range of g has to be a subset of that. Well, the range of G is reals and the domain of F is reals positive, so no, this does not exist. I'll change colour. Let's look at Goff. Okay, looking at the range of F, the range of F has to be a subset of the domain of G. Yes, it is. So Goff is fine. Any questions there? So fog.
Does it always matter between X and Y?
Sorry?
You know how why is it the FOG is not defined when it comes to X greater than 0, but when it's Y is greater than 0, it's defined?
No, fog F of G is not defined because I'm looking at the range of G, and the range of G is reals, okay? And the range of G has to be a subset of F. So for fog, range of G X has to be a subset of the domain of F of X. The range of G of X is reals. The domain of F is reals positive. It's not a subset, is it? How can you have it bigger than the reals positive? So that's not.
Oh, I see now.
Okay. While we do the other one, which is Goff, we want F range to be a subset of G domain. F range greater than equal to 0. So 0 or greater, I'll say reals positive. Is that a subset of reals? Yes, it is. So this one is defined. Does that make sense?
Yes, I get it now, because reals positive and reals negative are both subsets of real.
Right.
And you can't end because real can't be in real positive because real positive is half of real.
That's right. So Goff is defined as range of F is a subset of the domain G. And we could write range of F being reals positive is a subset of reals. Okay. Any other questions there?
So you could write X is greater than 0, Y is greater than 0 as real positive.
Yeah, of course you can. Yeah, of course you can. Reals positive, that's all it is, just the positive numbers. Okay, here, this graph here, that's the reals that are positive numbers only, and then for the Y, that's reals that are positive only. So you can write either greater than equal to 0, or you can write the reals positive, it doesn't matter. Okay.
Right.
Part B says, for the composite function that is defined, and there was only one, the Goff, state the domain and range. Okay, well, the domain of Goff. Now, remember up the top, we said that the domain of Goff actually equals the domain of F function. Now, in this case, the domain of F, and I won't write it as X being greater than equal to 0, I'll just write it as reals positive. Okay, including the 0. And then it says, state the domain and the rule. Okay, so I better write the rule down. I thought I worked out the rule, but obviously I haven't. G-O-F of X. Okay, substitute my F into my G, so I get 2. The square root of X minus 1. Any questions on that one? Okay, I'm going to clear this and move on. Okay, example 6. Example 6 says, for the functions f of x equals x squared minus 1, where x is an element of reals, and g of x equals the square root of x is greater than equal to 0, state why Goff is not defined. Okay, well, we've got the domain and range written here, but I'll do it with you. The domain of f, they tell us, is reals. Now, this is just a parabola that's been shifted up down 1 to -1. So the range is from -1 to infinity. This is the square root of x, which we already know is reals positive and reals positive including 0. So why is GOF not defined? Let's look at the range of f. The range of f, is it a subset of domain of G? No, it's not, because domain of G is reals positive only including 0, and we've got to go down to -1. That's why it's not a subset. That one there means not a subset. Any questions there? Okay, part B. Part B is very interesting. It says define a restriction on F such that GOF, but with a star, okay, GOF with a star is defined, and then find GOF. Okay, now remember, for this to be defined, we need the range of F star to be a subset of the domain of G. So this is a little bit of playing around here. Okay, so the range of F star, okay, the range of F star has to be reals positive including 0, because that's what the domain of G is. It cannot be any bigger than that. That's can be smaller than this, but no bigger. Okay, any questions there? Better see if someone's emailed me saying they can't get in. Any questions there?
So you cut out for like half of that whole sentence.
All right, I'll start again. Now,
can you say that again?
Yeah, we can put a restriction. We can put a restriction on things to make it a subset. So here they want us to restrict it. It's not going to be called F anymore. It's going to be called GOF with F star, because we're restricting it. Now, the only way we can restrict this, remember, to make it happen, we need the range of this F star to be a subset of the domain of G. So range of F star can't be any bigger than this, reals positive, because if it's bigger than this domain, then it's not going to be defined. So we can restrict the range of F to be the same as reals positive including 0, which is the domain of G. So now it's a subset. Even though it's exactly the same, it's a subset. Does that make sense to you guys? So instead of making it from -1 to infinity, where it's too big, we can make it the same as this. And now it's a subset. Okay, but remember, for this, because if we're restricting the range of F, then we also have to restrict its domain. So for this to happen, the domain of F we need to restrict to a subset, and therefore we're going to restrict it from reals, but excluding -1 to 1. Okay, very important. So we've got our rule. There's our F star. Okay, with that restriction in place, because they ask us also to find GOF. So now we're doing GOF star, and we're still doing the same thing. We're just going to substitute it in. So we end up substituting that in, and we get the square root of x squared minus 1. Okay, any questions there? All right. If you've got any questions from previous exercise, please ask me.